when you have three sides given to you and you're asked to find the three missing angles. Okay, now in this case, there is kind of a, you can have either one solution or there might be no solution. But it's fairly easy to check for no solutions. If you remember from geometry, there's a way we can tell if three sides will make a triangle. And that is that any two sides have to add to be longer than the third side. So for example, if I had lengths 5, 6, and 7, I said, could these be the lengths of the sides? 5 inches, 6 inches, 7 inches. I just need to make sure the two shortest sides add to be something larger than that third side. So 5 plus 6 is 11, which is bigger than the third side. So this could be a triangle. And if this were my question starting out, okay, I know that I could find an answer. There would be a solution. On the other hand, if I had something like this, 1, 3, and 8 were the lengths of my given sides, I would want to check to make sure this could actually be a triangle. So I want to make sure the two shorter sides added together are larger than that third side, and they're not. 1 plus 3 is only 4. There's no way its skimpy little sides are going to reach for the side. If you think about it, here's an 8, and if you had a side length 1 and a side length 3, he could stretch out as far as he wants, but there's no way he's going to reach the end of that 8. Okay, so that is how you check. When you're given three sides and you're using the law of cosines to solve for the angles in the triangle, first check, make sure the two shorter sides added together are bigger than the third side. If they are not, then your answer is no solution and you don't need to go any further. Now, if you do go past that and forget to check, eventually you'll figure out it's wrong because you'll get an error. Okay, let's do an example. So solve the triangle ABC given the three sides 5, 8, and 12. So just like we talked about, the first thing you want to check when you're given all three sides is that the two shorter sides add to be something larger than the third side. So our two shorter sides were the 5 and the 8. 5 plus 8 is 13, which is bigger than that third side. So we're good to go. We can get a solution. The next thing I would do is just draw a diagram so that you make sure you label your angles and sides correctly. So here's A, B, and C. A is length 5 is across from our angle A, B is length 8 across from angle B, and C is length 12. Okay, next you choose an angle. Here you can choose which angle do you want to find. It really doesn't matter. I'm going to find angle A. Okay, so we start with the side length squared. This time I know the side length, it's 5. Okay, I'm going to start clear up here. So the side length is 5 squared for A, plus the other two sides squared and added together, that's what the rule says, minus 2 times those two sides multiplied again, so times 8 and 12 in this case, times the cosine of our angle, which we don't know, I just know it's angle A. Okay, we want to simplify here, so we squared, 5 squared is 25, 8 squared is 64, 12 squared is 144. Here I'm going to multiply my 2 times 8 times 12 so that I can simplify as much as I can. Okay, and I get, that's minus 192, and again, cosine A. We're going to combine like terms here. So 64 plus 144, I can't combine it with this 192 because it's got a cosine attached. We'll have to deal with that different. Okay. But we can combine these two, and it gives us 208 minus 192 cosine A. I'm going to subtract 208 from both sides. So minus 208 gives me negative 183 equals negative 192 cosine A. Divide both sides by negative 192. Now, if you had one that's a no solution, this is where you would go, okay, no solution, because you're going to get something over here that's larger than 1. But we don't, because this does have a solution. We end up with about 0.9531. I'm going to leave that in my calculator, because to finish up here and get cosine out of there, I do the inverse cosine or arc cosine of both sides. Okay. And so I do the inverse cosine of that number that's in my calculator. And I get about 17.6 degrees. Okay, so I found one of my angles. Now to find the next one, you can either use the law of cosines again, only with angle B or C, or you can use the law of sines. I think the law of sines go a little faster, so that's usually what I use, and that's what I'm going to use here. And it's also good review. Okay, so I choose which angle I would like to find next. I'm just going to go in alphabetic order. I'm going to find B, but it really doesn't matter. And like I said, I'm going to use the law of sines. So remember, sines, you match up your side and your angle, and you do the length of the side. So the ones I have are A. So the length of side A is 5 over the sine of angle A. Angle A was 17.6 equals B, since I'm finding angle B. B is length 8 over the sine of B. I don't know its angle. That's what I'm looking for. I cross multiply, and I get 5 times the sine of B equals 8 times the sine of 17.6, and I would divide both sides by 5. Okay, again, you can use the law of cosines to find that next angle. That's totally okay. I just think the law of sines goes a little faster. Okay, that gives me the sine of B is equal to 0.48379. We want to remove that sine, so to do that we do the inverse or arc sine of both sides. And what do we got? We get about 28.9. Okay, so I have my two angles. I have a 17.6, okay, and then we need to find our last angle, which is, this is the easiest one to find, because once you have two of the three angles in a triangle, we know together they have to be 180. So we finish up here, we find out what our sum is so far. So far we have a 28.9 and a 17.6, and we want to find out what's left. And then we subtract that from 180. So angle C is fairly large. It's 133.5. Okay, so you really could use the law of cosines to find all three of those. But I used the law of cosines to find my first. That's a half 2. I used the law of sines to find my second, and then to find the third angle, I used the fact that the three angles in a triangle add to be 180. Okay. Here's our next example. It wants us to solve triangle ABC, which means find all the missing parts. We're given 3 of the sides, none of the angles. Again, the first thing you want to check when you're given all 3 sides is that it will actually make a triangle. So you want to add the 2 smaller sides together, make sure that that number is bigger than that third side. So my 2 shorter sides were 2 and 4. Well, 2 plus 4 is 6, which is not bigger than 10. So this is actually just plain old no solution. I don't even have to do anything else. And the reason is, from geometry we know the sum of the 2 shorter sides of a triangle have to add to be larger than that third side, and in this case they are not. Therefore they would not even make a triangle, so we don't need to bother. Okay, here's another. So again, we're asked to solve the triangle. We're given all 3 sides, so we know we have to use the law of cosines. Let's make sure this actually forms a triangle. So again, you take the 2 shorter sides, in this case 10 and 12 are shorter than 14. 10 plus 12 gives me 22, which is definitely larger than 14. So this is a triangle, and I do have a problem to solve here. Okay. So let's start. Here's our triangle. We're going to label it out, A, B, and C. We don't know any of those. We do know the sides opposite them, however. Opposite the A is length 10, Opposite B is length 12 and opposite C is length 14. Okay. Choose which angle you want to find because it really doesn't matter at this point. I'm going to go ahead and find angle A, but you can use any of them. I'm going to use the law of cosines because that's the only thing that will work right now. So for law of cosines, whatever angle you're looking for, you start with the angle opposite that is going to be by itself on one side of the equation. So 10 is my little a squared equals the other two sides squared. So 12 squared and 14 squared added together. Minus 2 times those sides multiplied again, so times 12 and 14, times the cosine of angle A, which we don't know, so we're just calling it A. We simplify, so 10 squared is 100, 12 squared is 144, 14 squared is 196, and here we multiply negative 2 times 12 times 14 is 336. Okay, so I have 144 plus 196 minus 336 cosine A. Combine your like terms. 144 plus 196 is 340. And again, I know I'm writing out every single step, but that's just to make sure you have the steps. If you can shorten this up again safely, you're welcome to. Okay, here I would need to subtract the 340. We're trying to get that A all by itself and doing that one step at a time. So I get negative 240 equals negative 336 cosine A. We would need to divide both sides by negative 336, which gives me a positive 0.7142 about approximately. Okay. Again, I left the whole thing in my calculator for this next step. To remove cosine, we do the arc cosine or inverse cosine. It has two different words you can use for it. Either way, you just put that in your calculator. Inverse cosine of that number gives us 44.4 degrees. So I found my first angle. My first angle is 44.4 degrees. All right. Next, pick another angle, B or C, which do you want? I'm going to go ahead and find B, and rather than going through the law of cosines again, I'm going to go through the law of sines. I make less mistakes that way. Okay, so I have a pair now. I have angle A and the side opposite. So for the law of sines, remember you put the length of the side, the sine of the angle opposite it. So we'd have 10 over the sine of 44.4 equals, I'm finding B. I decided to find B. So the length of side B is 12 over the sine of angle B. We need to solve for B. I'm going to cross multiply to get it out of the denominator. We got 10 times the sine of B equals 12 times the sine of 44.4. And then I would have to divide both sides by 10. I get the sine of B equals, I'm going to calculate this, 12 times the sine of 44.4 divided by 10 gives me 0.83959, and it goes on from there. I'm leaving it in my calculator so that here, to remove that sign, I do the inverse sine of both sides. So B is the inverse sine of that number 0.83959, which leaves me with about 57.09, 57.1 degrees. So I found my second angle, 57.1 degrees. My third angle is going to be a breeze because I just used the fact that these three angles should add to be 180. So let's see. So far, I have 44.4 and 57.1 for my two angles. That gives me 101.5. I'm going to subtract that from 180. I should do this more algebraically sound, but sorry about that, being lazy. And I get that there is 78.5 degrees left in that triangle for angle C. So I solved it. I found angle A using the law of cosines, angle B then using the law of sines, and angle C, due to the fact that the angles in a triangle add to be 180.